Alright, so in today's video I'm sharing with you a few exercises here that goes over a technique that you can use to subdivide a panel and then be able to array it to create something like this. Now this is just one of the options. We can change all of the parameters here by pulling on this one. This is point on curve. This is going to change one of the locations for the points, but we can also have, you'll see other modifications like the rotation of this. If we put this at 30, it actually truncates it in a different location. So what this does is let you create a dynamic pattern to be able to pick whatever is comfortable for you and your designs. And so if you want to download this, check out my website, capettidavid.com. I'm going to have this one available for you guys to download so you can see how it all comes together and also so you can use them yourself. This is just one idea. There are infinite and very unlimited number of things you can do with this. So it's up to you how you take this to the next level. Let me know what you come up with. I would love to see it. Other than that, let's get into the tutorial, and you'll also see another work session. So you'll see a few different exercises that will be useful for creating patterns like this. Alright, so to start the pattern, we need to bring in a base geometry to create the pattern. Now you can use many different patterns. What I like to use is a grid with hexagons. That's what we'll be using for this exercise. But let me show you what's interesting here, is that in Grasshopper, when I double click here and I type in grid, you would think that we would be able to find different kinds of grids within the options here, but sometimes you can't find it intuitively when you type in, let's say, grid. If you go to the top here, you go to vector grid, you'll see that it's actually labeled under triangular, square, rectangular. We'll be using the hexagonal one. Now with this, we have 4 different inputs. We have the plane input, which is where it's located. We have it at the origin, the size, which is the size of each hexagon, and then the extent. So let's plug those in. We can go to XY plane. Also, we can change that to, let's say, an XZ plane. Notice that now it's standing up. Now the size, let's give it a value. So we'll go 15.00. And let's change the extent to 3 less than 5 less than 15. So now we have the extents here. We can decrease it because at the beginning, if we have less, it's a little bit easier to work with. Okay, so now with this, we can get started creating the pattern. So I'll hide both of the inputs here and I'll select just one of the cells here. Now when you look at the outputs here, we have the cell and we have the points. But the thing is, we don't really see any points. If we plug in the point or bring in an empty point component and plug in the points into it, you'll see that the points here are actually referencing the center of each of those hexagons. So now we need to select one of the cells. I'll go here to item or list item and pick one of the cells. Now notice that when it comes in as a dashed line, that means that it's grafted. And when the information is grafted, that means that it's coming in sets, which means this is one set, another set, and another set. What we need to do is flatten the input. And what this does is it'll put all of them in one list and select the first one. That's the same thing that we need to do with the point. But what we can do is we can actually recreate that center point. So let's disable the preview. And now we've selected just one. We can always bring back the grid. But what this will do is let us develop this into a pattern, and then be able to array it to all of the cells. So the first thing we're going to need, the first component we'll bring in is discontinuity. And this will give us a point at every intersecting, or at every time it turns a corner. So let's go here to curve input. Now that we have this point, we want to get the midpoint. And one way to do this is to bring in the average. And this will let us use the average of all those points, which will result in the center point. And what we want to do now is extract a series of points that we can use to create the overall pattern. So now that we have the outer points and we have the center point, let's create a line between those two, starting at the center and ending at the corners. So what we've done is we've created the outer point, center point, and now we're going to extract a point within that curve. So here we'll go to point on curve, and there are other ways that we can do this, but point on curve is a visual way to do this. Notice that when we plug this in, we can extract a point using 0 to 1, which reparameterizes this curve, and now we can extract a point, and that's going to serve as a guide to subdivide this entire cell. So let's go in here, we'll bring in a Voronoi component and start plugging in the points, and I can show you what the pattern can look like. So starting with the first one, continuing on with the center point, holding down shift, adding an input, flatten the input. Notice that we're getting something here. And then using this one, let's plug those in too. Now we can change that like this. So what we need to do now is create a surface on that hexagon. So we'll go to boundary surfaces and use these cells also as surfaces and see where they overlap. So I'll bring in intersect, physical, vrep, and now where those two overlap, it will extract the geometry. So now here, I can go to boundary surfaces again. And we can change the pattern like this. Now the next thing we need to do is take this cell and move it to all of the other ones to see what the pattern would look like. And the way we would do this is to take this center point and create a line segment between this starting point and the end point or the midpoint of all of these other cells. Now we're going to take all of these surfaces, I'll flatten them, and we're going to move all of these in this direction. Now we actually need to graft the motion here. And now I'll disable the preview and show you what this can look like. Now if we expand it, it'll make more sense. Now check this out. This is a fairly small set of steps that we've done here. Let's move this out of the way. Just want to clean this up so it's a little bit easier to read. All right, so now at this point, what we can do is take all of these and bring in an area component so we can evaluate what size and what the area is for all of those. So I'll actually flatten the input here. And when we look at the area, we have different areas. Obviously the smaller ones are going to be smaller, and so what we want to do is color those into separate colors. Now how we do this is we need to deconstruct the domain or deconstruct the minimum and maximum areas so we can color these accordingly. Now the way to do this is deconstruct domain, and we'll plug in the area. Now we have the start and end. Now we can bring in a gradient. We'll bring in the start and end here. And for the parameter, it has to be a number between the start and end, which we can do by creating the average of the start, the average of the end, and doing a division by 2, and using this as the input. So now we actually don't need the start one. Now we can bring in a color or a custom preview and be able to color all of those objects which we need to flatten the input for. Now we have colored it within the small ones are going to be the blue, the large ones are going to be towards the red. Now I just need to disable the preview on all the points and everything so we can see it a little bit more clearly. And we're seeing that even though these two shapes are different, they're actually similar size. So if we went to 0.5, just changing the presets here just to see what it looks like. What this one has that's different is that it has a lot of changes within, like a lot more changes, so it'll be more subtle when we move this around. So technically we can call this option 1, right? Because this turned out to be pretty cool, but let's add more points to that cell. So let's go in here and look at these points. And notice that those points are, we have 6 of them, So we're going to go to list item. And we're going to click down here. So we have 1, 2, 3, 4, 5, 6. And if we remove one, you'll see that it removes the last one. So with these points, what if we create an average between the first two and the last two? Or no, maybe between these two. So the ones across, and add those to the Voronoi pattern. Okay. It's all right. See what happens if we do the next one. Then the next one. The next one. Next one. One more, which is this and this. So if we take all of those and plug them in together, so I'm actually going to be doing those first. So I'll take this and actually disable it because it's getting in the way. Now that those are plugged in, we also have to do the center one. We also have to do this one. And this one. So now, if I disable the preview on some of these points, we basically truncated and created a different, completely different pattern just using that. All right, so the next thing I would want to show is, okay, so let's say we have those two patterns. Let's add one more modification here. I'll actually be going to the center point of this, creating a circle with a radius. We'll just give it 1.5 or so. Maybe I need some more. And then divide this by 3, less than 6, less than 9. And those points, adding those to the set, which means that we can actually change the size of the circle, which has those points, which can then alter the entire set of geometries just by pushing this in and out. Now, obviously the colors here, maybe they're not the best for presenting this. Let's see if we can change that. Now you're saying that we can literally use any set of points here. Now we have 6 here. We have 4. This one you have 3. And the size of this. So the truth of the matter is that when you're creating tiles like this, you can really create your own set of rules. For me, I like to follow the natural shapes. So if, let's say, we picked this cell, well, we know that we're going to extract those points, the midpoint, a point along those, and then the only one that would be a little bit more random is using a circle with points. So with that being said, hopefully you enjoyed this little bit, and let me know if you have any questions.